Okay, so watch and listen carefully here, guys. So for question number 1, we are given the orbital period of this satellite being 9.87 hours, okay, which we'll need to convert to what? Seconds, yeah, okay, because we can't use Kepler, it's orbiting the Earth, okay, so we have to convert that to seconds, so that'll be our first step, okay, 9.87 times 3600, and it gives us 35,532 seconds. Okay, so that's it. That's our given, so we get a mark for that. All right, then we know it's orbiting Earth, so we know the centripetal force is being provided by the force of gravity. Okay, and that means we're going to have to use m times 4 pi squared times r over t squared, because we're given the period, not the speed, and not given any way to calculate the speed either. Okay, and then we have big G times the mass of the Earth times mass over r squared. All right, so if we are going to manipulate and find the height above the surface, it's actually going to be two calculations. First, I'm going to have to calculate the radius, and then what am I going to have to do? Subtract the Earth's radius from that to get the altitude. Okay, so first thing is move the r's over so they're on the same side together. R squared times r is r cubed. Sorry, give them a mark if they got that step there. Okay, then we got to manipulate, so we're going to have r cubed. Okay, right here, we're going to bring t squared over to this side. We're going to divide by m 4 pi squared, which will leave 4 pi squared on the bottom and cancel that m away. So here's what we're left with. Okay, r will equal the cube root of big G times the mass of the Earth times t squared divided by 4 pi squared. They can have a mark for that for their third mark. Okay, or maybe they went straight to plugging in the numbers. If they did, that's fine. Okay, so square root of 6.67 times 10 to the minus 11 times 5.98 times 10 to the 24 times 35,000, 35,532 squared divided by 4 pi squared. Okay, so they can have a mark for that. Or sorry, they already got a mark for that. Okay, so that's going to mean our radius, orbital radius, okay, will be math 4. Okay, so there's our orbital radius, but we still need to subtract from that the Earth's radius. Okay, so if they have that number, or they've shown that the actual orbital height or something like that is radius minus 6.37, okay, either one, times 10 to the 6th, if they have either one of those steps, that's their fourth mark, okay, and their fifth mark will be for actually having the correct height. Okay, so we'll be subtracting 6.37 E6. Okay, so our actual height, and we have 3 significant figures in that question. Okay, our actual height will be 1.70 times 10 to the 7 meters. Fifth and final mark. Okay, questions on number 1? All right. Okay, question number 2. 2 ways to do it. You can solve it as an FC equals FG question, but you can also solve it as a Kepler question, and it'll be a lot faster. Okay, so I'll show both ways here, but if I'm solving it as a Kepler question, actually, no matter which way I'm solving it, they get a mark for givens. Okay, so the radius will be 3.5 AU, okay, or 8.5 or 5.25 times 10 to the 11 meters. Okay, either one of those. Okay, we're looking for the orbital period. So that's their only given. They get a mark for that. If they're solving it with Kepler, okay, then we're going to go period of the Earth squared over radius of Earth's orbit cubed equals period of the asteroid squared over radius of the asteroid's orbit cubed. Okay, so that can be their second mark for identifying they could do it that way. Okay, we are solving for the period of the asteroid, so we would multiply both sides by the radius of the asteroid cubed. Okay, so if they have that manipulation or they just have the numbers plugged in, whichever, okay, that's fine. So the period of the asteroid, okay, will equal the square root of the radius of the asteroid's orbit cubed times the period of Earth squared divided by the radius of Earth's orbit cubed. Okay. And so that is going to give us, sorry, we're at 1, 2, okay. So this can be 3 here. So that'll be 3.5 times 1 squared over 1 cubed. So essentially we're looking, okay, at the square root of 3.5 cubed. Not alpha. Okay, so its orbital period will be 6.54 years. Sorry, 6.55 years. Okay, and that'll be their fourth mark. Did anyone solve it as a satellite motion question? Okay, so just quickly here, if we're solving that as a satellite motion question, then we have FC equals FG, okay, and we'll have M 4 pi squared times R over T squared. It's big G times mass over R squared, okay, and we're looking for the period. So we're going to have R cubed over here over big G times mass of the sun, okay, mass of the Earth will cancel, okay. Like I say, we've got T squared over here. So it's actually going to be a slightly different number doing it this way. Okay, so T will equal the square root of 4 pi squared times 5.2, was it 25 or 24? 5.25 times 10 to the 11. Okay, and that is cubed divided by 6.67 times 10 to the minus 11 times 1.99 times 10 to the 30. Okay, divided by and then I got to square root that. Okay, so we get 2.07 times 10 to the whatever seconds, okay, which is the equivalent of 6.5 years. Okay, all right, any other questions on that one? All right, so give them a mark out of 9, okay, on that. Let them see it, and then let's put them on the desk in front of Cohen there.